Hello guys, welcome back to my channel. So today we're going to build a side-to-side VPN tunnel. We've seen side-to-side VPN tunnels before in my previous videos, and so today we're going to use a Cisco GRE, generic routing and encapsulation. It was developed by Cisco in 1994, and so that's what we're going to use today to build this tunnel, linking R1 and R2. So the goal here is to make sure that our traffic from the site 1 to site 2 gets through the tunnel, and the ISP, the internet provider, should not be able to see it. It's not a very secure protocol, the Cisco GRE, but it gets the job done. We have traffic going from R1 to R2. So this is the prototype of what we're going to implement today, and so I'm going to show you how it works, and before we get to configuring, bring up our devices and configuring them. For the IP scheme, we're going to use 192.168.10.0 on site 1, and on site 2 is going to be 192.168.20.0, and then the internet facing IPs on the site 1 is going to be 64.64.64.0/30, and then 65.65.65.0/30. Just to show you how it's working, I made a screenshot of the diagram that I have here on the right. So if you go to the ISP, router, we should not be able to see the LAN networks of either R1 or R2. Okay, so if I do show IP route, okay, so we see only the directly connected network. We don't see the LAN networks. Okay. Now, if you want to see the LAN network, you have to go to R1 or R2. Let's go to R1 first. We'll show IP route. Okay, so you can see the 20 network, which is coming actually from the other side, on the R2 side. On the R1 side, we're able to see that network, and that network, as we see here, it's coming through tunnel 0. Okay, so that's the tunnel we're going to create, a GRE tunnel. So it's a GRE protocol that runs over IP. So now if I have to ping, if I want to ping the 192.120.1, okay, which is the IP address I gave on the other side. So I'm going to source the traffic from 192.168.10. That's our network .1. Okay, going to source the traffic from here, and you see the ping is responding, so which means our tunnel is up and running. Okay, but if I come here, I made a ping from R1, which means that our ping, technically the ping is going through to the ISP and then R2, but the thing is we created a tunnel, so ISP and they're not seeing anything. So if I come to ISP and then I'll try to ping the 192.168.20.0. okay, if I try to ping any IP on that range, I should not be able to. So if I do ping to 192.168.20.1, so that ping is not working. It's not working because ISP doesn't know how to get there. Okay, so that's the goal of our goal today, is to configure that tunnel. Okay, so right now I'm building a similar network, okay, just similar to the one we saw here. So I'm going to build it, and then we configure the tunnel together. So I put the routers. I have to change their names. I'll give this one ISP. With ISP. And then I'm going to add some PCs. So I went ahead and added one more PC and make sure the connectivity is there. So I need to just complete the diagram and then power it on. Alright, so the full diagram now is completed with the IP address schemes and designated, and also the title. Everything is there. The only thing we haven't done yet is make sure the configuration is there, and also the devices are not powered on. So what I'm going to do right now, I'm going to power these devices on, and I'm going to start the configuration. Okay, devices are all powered on. Okay, again, like in all VPN setups, the first thing we want to do is to make sure that globally R1 is able to reach the ISP, R1 is able to reach R2. Okay, so these three devices have to be globally connected first before even doing the configuration of the GRE tunnel. So that's the first thing I'm going to do. I'm going to make sure that the R1 can talk to ISP, R2 can talk to ISP, and R1 can also talk to R2. The only thing they cannot see is the LAN networks. Okay, so at the moment I completed global configuration so that R1, ISP, and R2 can see each other through OSPF. So if I go into, let's say R1, if I go into R1, I say show IP route. Okay, so if I go to R1 and see show IP route, I don't see the route to, I don't see any route to the 20 network. Okay, let's see. Okay, if I do show, for some reason, okay, show IP route. Okay, so right now I don't see any route to the 20 network. Okay, I do see a route to the 65 network. Okay, so which means if I do ping the other side, that's the R2 65.65.65.2 is the IP address on the R2. Okay, that ping is not working for some reason. Okay, I know what happened. Actually, what happened is that I made a configuration and added it on the configuration that was supposed to be on R2 router. I added on R1, so that's made the made the network not to work. So right now we can see we have global connectivity between R1, ISP, and R2. So if I do from R1, if I do show IP route, before then let me do show IP interface brief. So this is the IP I'm giving to the .2 is always going to be on the router end. Okay, on the edge router end. So .2 on R1 and then .2 also on R2. Okay, so the R2 is going to be 65.65.65.2, and then I also configured the loopback. Okay, it's actually representing the PC that you have here. It's just quicker for me to do with the loopback. Now I also make sure that there's global connectivity. So which means from R1, if I do ping, if I ping 65.65.65.2, ping should be working. But if I ping the LAN IP on R2 side, I should not be able to. So IP is 192. Okay, ping 192.168.20.1. that ping should not respond. Okay, and the reason it's not responding is because we don't yet have the GRE tunnel configured. Okay, GRE tunnel is not yet there, and so we don't have, so the R1 doesn't know how to get to that network. Okay, so right now we're going to start the GRE tunnel configuration. So before even we do the GRE tunnel configuration, if I do show IP interface brief, okay, we should not see any tunnel interface here. Okay, we don't see any tunnel interface. We see a loopback, we see fast Ethernet, we see serial interfaces. We don't see any tunnel interface. But right now we're going to configure a tunnel interface. Okay, we're going to configure a tunnel interface as I said. So this is the configuration right here at the left. We have the tunnel interface. We give it an IP address. We'll give it an IP address, and then we have to inject in that tunnel OSPF. OSPF instance 100, area 100, and then we put the tunnel in gray mode, over IP. Okay, and then we define its tunnel source. It's going to be serial 00. Okay, so if you check here, this is the tunnel source. As I said, the traffic actually goes through the ISP, but ISP doesn't see the LAN network. So this is a real tunnel source. Okay, tunnel source serial 00. And we define the tunnel destination, which is the one IP of R2. Okay, so this is the configuration. That's it. And also we have to inject OSPF. We have to inject OSPF route into the loopback interface that we configured. Okay, so I'm just going to copy here and paste in R1. Okay, so R1 side is done. Now for R2 is the exact same thing. Okay, except that we're going to have to use a different IP address for the tunnel. So on the tunnel 0 of R1 was .1. On R2 is going to be .2. Okay, so also have to inject OSPF into that tunnel. Okay, so area instance 100, area 100. Tunnel source is going to be CR00, and tunnel destination is going to be the other end. Okay, that's the 64.64.64.2. That's the R1. Okay. Also, we make sure that the loopback interface is injected into OSPF. Okay. So we're just going to copy here. Just going to copy and paste into R2. Okay, and once this is done, okay, how we're gonna know that we now able to see those routes? Just go to any one of those routers. Let's say we go to R1. We'll do show IP route. Remember before when we did the same command on R1, we were not able to see the 20.1 network, the LAN network on R2. We are not able to see it before, but now we can see it, and we're seeing that it's coming through the tunnel interface. Okay, so if we do show interface tunnel 0, show interface tunnel 0. Okay, so we see the tunnel is up. Okay, and we can see the IP address. Okay, we can see all the configuration we did on tunnel 0. We can see right here. And one last test that we have to do is just to ping. You can ping the 192.168.20.1. Okay, and we're going to source the traffic from our loopback interface, which is 192.168.10.1. okay, which means we're pinging LAN to LAN. Okay, ping is successful. So what we did right now, we're able to ping, let's say, from this PC to the other PC. Okay, technically traffic is going through ISP, but ISP doesn't know about it. And to prove that, if you go into ISP, we'll do show IP route. So ISP doesn't know about those 192.168.20.0 or 10.0. okay, and even we do a ping. We did that before, but do it again. 192.168.20.1. So ping cannot work because ISP doesn't know about those routes. So basically, this is it about GRE tunnel. It's fairly simple, but the thing is, GRE tunnel, as I said before, is that it's not secure. there's no encryption of data, so anybody can intercept that traffic in the middle, and they'll be able to like extract data. So in the next videos, we're going to see how we can secure a GRE tunnel. We're going to configure GRE over IPsec. Okay, so that's going to be our next videos. Thanks very much for watching, and talk to you next time.